What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to look at our lesson 2.1, Angles and Congruence. So we'll talk about how to analyze figures using definitions of angles, parts of angles, calculate angle measures by using congruency and angle bisectors, and then be able to talk about a little bit of adjacent angles, linear pairs, and vertical angles. We have a lot of definitions here. So what I'm going to do first is type our definition and then draw a picture. So array is our first part, a part of a line consisting of a point on the line. So here would be a good picture drawing. We were going to have ray AB. So we make a point and an arrow to one side where A would be one point and B would be the other end, but notice how B is on the end where it keeps going. So we can even notate that as AB with an arrow on top. You could also have multiple points on the array, like A could be first, B could be in the middle, and then C at the end. This ray could be, you could still name it AB because B is still on the end where it's continually going. You could also name it AC. Okay. Opposite rays are next. Opposite rays are two collinear rays with a common endpoint. Would help if I would spell that correctly. So what that looks like is we have maybe what's going to look like a line, but you're going to have a point in the middle and then your points on the side. So these rays can be ray AB, and then you can also have ray AC. Okay, as long as you're starting with A being that endpoint and then C is towards the arrow or B is towards the arrow. Okay, straight angles, those are going to be formed by opposite rays and they're equal to 180 degrees. So really similar to how you just drew opposite rays, because those opposite rays were making that straight angle. So again, we have, here's an example. A could be in the middle. You can have B on the side and then C on the other side. Okay. Angles, that is when you have a pair of rays that have a common endpoint. And we'll talk about what that endpoint is in a few examples here. We are going to see an angle drawn together with two rays. I'm recording a video right now, so I'll be done in a little bit. Thank you. Sorry, the custodian was just trying to come in and clean my room. Here would be ray AC and then AB making that angle, and you can name that angle CAB. Okay. The next one we have are sides, and sides are just rays that make an angle, form sides. So when we have this picture here, I'm not even going to label this with letters. This is a side, and so is this. Okay. A vertex is when you have your angle. I'm going to go and draw a picture first. The point where the angle comes together. So that definition will be a common endpoint of an angle. And then for interior and exterior, you can have what we call just any type of angle, and interior points would be inside of that angle, whereas exterior points are going to be outside that angle. So this would be considered inside angle. And then here would be outside the angle. Okay, so example one, we're going to name some examples here that have a vertex of X. There's a lot of them, so just hang with me tightly. A first angle could be TXY or TX all the way to Z. You can have angle TXW. We see angle TXU. And then you can also use some with W's. WXY would be an angle, WXU, and angle WXZ. So 1, 2, 3, 4, 5. And then from there, you could also just rewrite these backwards. Like ZXU would be a good one to use, or ZXW was already used. So was TXZ. You could do angle ZYX, or sorry, nope, that wouldn't be it. ZXW was already used. So yeah, those are all the ones that have a vertex of X, okay? The sides of angle 3 are going to be XW, and that's a ray. And then the other side of angle 3 would be XU, ray. So ray XW and ray XU. Name a point in the exterior of angle 3. So here's the exterior of angle 3. A point would be point T. That's on the outside of it. And then name a pair of opposite rays. Any ray would do here. I would just say like XT and XU would be a good example for opposite rays. Okay. Some more definitions here. We have congruent angles. Congruent angles are angles that have the same measure. So we're going to draw an example of that here in a second. And then an angle bisector is a ray or a segment that divides an angle into two congruent parts. Okay, so let's go ahead and draw some examples to see what that look like. Congruent angles can be drawn many different ways. I'm going to show you one way here because this is going to connect with our angle bisector. Congruent angles would just have two little arches in the middle of them to show that they are congruent. So maybe we have this as point Q, point T, point S could be here, and point R. So I could even say that angle Q, T, R is congruent to angle S, T, R, okay? And then angle bisector is just when you have that middle number or that middle segment dividing an angle into two congruent parts. So again, still can use Q, T, S, and R. And we're seeing that it's being bisected because both of these angles could be equal to the same degree measurement. Okay, so again, we see the measurement of angle QTR is equal to the measurement of angle STR. Okay, so in example 2, this one might have had an error on your paper, so just make sure it's reading this. And the figure, ray BA and BC are opposite rays. Okay, cool. And ray BD bisects ABE. So that means half of ABE is equal to the other half. So it's reading if ABD is 4x plus 14 and the measurement of DBE is 8x minus 32, find the measurement of DBE. Well, we know they're equal to one another, so we can set these equal to one another. 4x plus 14 is equal to 8x minus 32 and start to solve for x. I'm going to subtract 4x from both sides, add 32 to both sides, and I'm going to end up getting 46 is equal to 4x. When I divide both sides by 4, I'm going to get a decimal here of 11.5. So I would plug that 11.5 in to find the measurement of angle DBE, which is 8x, or 8 times 11.5 minus 32, which would give me the measurement of angle DBE. I'm going to get 60 for that. Okay, looks good. Let's go on to example 3 on the next page. Just a few more examples and then we'll finish up here. So in the figure again, ray KJ and KM are opposite rays. KN is bisecting JKL, so JKL, that means this and this are congruent. So if JKN is 8x minus 13 and NKL is 6x plus 11, find JKN. Well, we're just going to set those two equal to one another. 8x minus 13 is equal to 6x plus 11. Go ahead and get all of our x's to one side and all of the constants to the other. Double elimination here, so 2x is equal to 24, so that means x is 24. So JKN, the measurement of JKN, is equal to 8, not x is 24, x is 12. 8 times 12 minus 13, and that's going to give us 96 minus 13, or 83. So the measurement of JKN is equal to 83 degrees. Okay? Excuse me. 3 more vocab terms, and then we'll finish up with some more examples. So, adjacent angles. This is when you have 2 angles that have a common side and a vertex. Again, we'll just write all these definitions down first, and then go back and draw some pictures. Linear pair is a pair of adjacent angles with non-common sides that are opposite rays. And I'll show you what non-common sides means in just a minute. Linear pairs are also equal to 180 degrees. The last one, vertical angles, are 2 non-adjacent angles formed by 2 intersecting lines, and they are also congruent. Okay, so let's draw some pictures just so it makes a little bit more sense here. When you are thinking about adjacent angles, sorry guys, you're going to think about 2 angles just right next to one another. So, like this. Angle 1, angle 2. Okay? Adjacent angles are not this. Like you have, here's angle 1 and here's angle 2. Those are not adjacent. They're right next to one another, but they don't have that common side and a common vertex. Okay? Linear pair, a pair of adjacent angles that equal 180 degrees. So maybe I have like 50 degrees and 130 degrees. That's a linear pair. And then vertical angles, 2 intersecting lines, 1 and 2. And then I'm going to name all these angles just numbers. 1, 2, 3, 4. When you look at these lines, the ones that are across from one another are going to be congruent. So angles 1 and 3 are vertical, and angles 2 and angle 4 are also vertical. Okay? So once we have these written down, we're going to try some examples with that. An example for 4, name an angle vertical to 4. So here's 4. The angle that's vertical to 4 is angle 6. So it's right across from it. Name all angles adjacent to AGC. Here's AGC. So I can say angle CGB and angle 3. I couldn't do A3H. That would be a weird thing to say about an angle. And then 2 linear pairs. This one I would just use numbers, so like angle 1 and angle 2. Or you can even say angle 2 and angle 3 because they're making 180 degrees or a straight line. You can even go down here at the bottom, angle 4 and angle 5, and angle 5 and angle 6. All those are linear pairs. And then the last part of this, we're just finding the values. These are vertical angles. So to find the value of Z, these are going to be congruent. So 8Z minus 3 is equal to 7Z plus 7. So to solve that, I'm just going to move all of my Z's to one side and all my constants to the other, and I'm going to get my answer right away. Z is equal to 10. And then my example 6, finding the value of T. These are linear pairs. So 9T plus 3 and 4T minus 5 has to be equal to 180. 9T and 4T is 13T, and then 3 and negative 5 is negative 2. So 13T minus 2 is equal to 180. Add 2 to both sides. I'm going to have 13T is equal to 182. And then if I divide that by 13, T is going to be equal to, let's see what I got for that one, 14. There we go. That'll conclude our video on our lesson 2.1, Angles and Congruence. Thanks so much for tuning in, and we'll catch you next time. Have a great day.